हेलो फ्रेंड्स। इस वीडियो में हम फोर्थ और फिफ्थ क्वेश्चन कवर करेंगे। तो हमारा फोर्थ क्वेश्चन है टू प्रूव सेट ए इक्वल टू एल ऑफ जी। तो देर आर फोर ऑप्शंस। First, it is enough to prove that an arbitrary member of A can be generated by the grammar G. Second, it is enough to prove that an arbitrary string generated by G belongs to set A. Third, both the above comments A and B are to be proved. Fifth, fourth, either of the above comments A or B is to be proved. Let's discuss each option in detail. To prove that set A is equal to the language generated by grammar uh, G of A equal to L of G, we need to establish a bidirectional relationships. Let's examine each option. First, it is enough to prove that an arbitrary member of A can be generated by the grammar G. This statement implies that if we can demonstrate that any string in set A can be generated by the grammar G, then it suffices to establish A equal to L of G. Second, it is enough to prove that an arbitrary string generated by G belongs to set A. This statement suggests that if every string generated by grammar G is a member of set A, then it is sufficient to prove A equal to L of G. Third option is both the above comments A and B are to be proved. This option asserts that we need to demonstrate both directions, that any string is in set A can be generated by G and that any string generated by G belongs to set A. Fourth, either of the above comments A or B is to be proved. This option implies that proving either statement A or statement B is sufficient to establish A equal to L of G. To determine the correct option, we need to recognize that to prove equality between two sets, we must establish that every uh, element of one set is also an element of the other set and vice versa. Thus, both directions need to be proved, which corresponds to option C. So, explanation for correct answer. Proving statement A ensures that every member of set A can be generated by grammar G. Proving statement B ensures that every string generated by grammar G belongs to set A. By proving both A and B, we establish the bidirectional relationship necessary to prove the equality A equal to L of G. Therefore, the correct option is C. Both the above comments A and B are to be proved. Now, question 5. Uh, so, question है the set A and Bn n equal to 1, 2, 3 can be generated by the context-free grammar. So, there are four options. First, A belongs to AB, A is B, S belongs to A, S, B, B, AB. Third is some non-regular languages can't be generated by any CFG. And fourth है some regular languages can't be generated by any CFG. Uh, so the language A and B and n equal to 1 to 3 consists of string where the number of A's is equal to the number of B's and each A is followed by a corresponding to B. This language is not like regular and cannot be generated by a regular grammar. Let's analyze each option. The first option है this production rule generate string where A is followed by B and A as B recursively generates string with an equal number of A's and B's. This CFG indeed generates the desired language A and B n equal to 1 to 3. So option A is plausible. Second option, this production rule generate string where A is followed by A, S, B, B or A, B. However, this CFG would generate string like A, B, 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 which contains more A's than B's, while violating the language constraints. So option B is incorrect. Uh, C option is some non-regular language can't be generated by any CFG. So this option is general statement about non-regular language and CFG. It's true that some non-regular languages can't be generated by any CFG, but it doesn't provide specific information about the given language. A and B and n equal to 1 to 3. So while this statement is true, it's not directly related to the question. Fourth option, this option is also also a general statement about regular languages and CFG. Regular languages can always be generated by a CFG, since regular languages are a subset of the language generated by a CFG. Therefore, this statement is false. Uh, Considering the analysis, option A is correct. तो ऑप्शन ए करेक्ट है क्योंकि द प्रोडक्शन रूल्स A belongs to A B generate the best case where the string consists of just one A followed by one B. The production rule S belongs to A S B allows for recursive generation of strings with an equal number of A's and B's. Therefore, option A correctly repeats a CFG that generates the language A and B and n equal to 1 to 3.